Hello everyone. In this third device modeling MBP Python tutorial, we will learn the MBP Python API. In the previous tutorial, we learned about the MBP Python project structure, the task group, and how to call an independent Python file within the task group. In this session, we will introduce the MBP Python APIs and how to use them for specific modeling purposes, such as loading data and generating plots. In the MBP Python API, there are 5 types of module packages. The corner module. This module contains functions for loading corner libraries into MBP. The MBP module. This module provides general APIs to interact with MBP, such as clearing data, loading data, opening projects, and more. The QA module. This module includes functions for quality assurance using QA Express in MBP. QA Express is a valuable feature that allows you to monitor fitting trends or accuracy during the extraction process, eliminating the need to wait until the entire flow is done before conducting quality checks. The MB data module. This module offers functions for handling data frames in MBP. Data processing is crucial in device modeling process, as it enables us to analyze various device characteristics with processed data to achieve an accurate model. We will provide more information about data frame in the next tutorial video. Next, let's discuss these Python APIs in more detail. This is an overview of the MBP Python APIs. The names of the modules typically indicated their purpose. For instance, the function getData is used to get data from MBP, while setData is used to input data into MBP. In addition, the related documentation can be found in the MBP Help menu, where you can explore more details about the available APIs, such as the type of input information that should be used with these APIs, return type, examples, and more. Please note that the APIs highlighted in black can be utilized in both the Python editor and MBP script. In contrast, the APIs marked in red are exclusively available in the Python editor. Next, I would like to show you how to internally call MBP Python API from the MBP Python editor. Using Python APIs internally in MBP is quite simple. We just need to import the necessary modules from keysight.devicemodeling.mbp in either independent Python file or task group. Next, I will provide a simple example to help you better understand how Python APIs work in MBP Python editor. In this demo, we will learn how to call MBP Python APIs internally to load data and display plots. In total, there are 5 steps to load your measured data and create different plots. Let's start from the beginning. First, open the MBP and create or load a project. In this case, we will create a new project and choose the bSim4 model for simulation based on our data type. Secondly, we will open MBP Python editor as introduced in the first video tutorial. Then we open the MBP Python editor and create a new project workspace by clicking the New Project button. Name the project Tutorial 3 and choose a location to save it. After that, click the Create button to set up the project. Next, create a new task group within this project by right-clicking on the project name and selecting New followed by Task Group. Be sure to assign a name to this task group. Now, you can edit the tasks by double-clicking on the task group. To create a new task, click this button and give the task a proper name, such as Load Data. To use the MBP Python APIs, we first need to import the necessary module from the Keysight.devicemodeling.mbp library. Additionally, we should import the OS package to manage files directories and interact with the operating system. Next, we need to set the path for the data file and use mbp.loaddata to load the provided data. It's also worth noting that you can define a common path in global Python file and use it across all your tasks for added convenience. To show plots we want to check, we can create a new task and use mbp.plot2minFrame to show different plots. For example, we want to see IDS with different VGS and VBS, with width equals to 10 micron and length equals to 10 micron, at VDS equals to 0.05 volt. We just need to give corresponding name in plot name and use it as input variable for plot2minFrame. Then, after execute this task, you will see the related plot shown in MBP main window. If you want to check multiple plots, just change plot name to a list and then run it. Then you will see multiple plots in the MBP main window. In summary, from this tutorial video, we introduce the MBP Python API and how to call this API internally in MBP. These APIs provide a more convenient way to process data and realize the specific purpose when we do device modeling. Next time, we will introduce data process using the MBP Python APIs. Thank you for watching.